Hello comrades, so today we're gonna learn how to make Tracer from Overwatch with different model, different everything, but you'll learn how to make blink like this, and if it moves into the wall then it stops, and you will learn how to make a recoil. So for example, we're making blink outside and then I press Q and it recoils. Recoil has cooldown, blink has cooldown, it gains charges, you can see charges, and you can see if blink is actually available right now. And here is recoil. Okay, so let's see what we can do. First off, I will show you the scene. Okay, we don't need this yet. Let's do this. So what we have, I have my model, which is called Anubis because apparently it's Anubis. You also can see it as an icon for my channel. We will need our model. It's rigged. I used Mixamo. You can see my other tutorial on how to quickly rig a character and also just animate it. I took all the animations from Mixamo. I didn't animate it myself, so it's all automated. I just had to enable it. We have our main camera that points at the character and is a child of the parent character object. So whenever the character goes, the camera goes after him. And I have a cube, which is just an obstacle in the scene. I have a field, which is just a plane, a little bit modified because I added box colliders, so it's like a little bit thicker than a regular collider. You can see that it's big. I just don't like mesh colliders for some reason. I guess there is a good reason, because they're very, very thin. And I have my canvas where I just put my text for how many blinks are available. Charges, I mean, for the blink. And the color of the text changes depending on if you can blink or not at the moment. So red you can't, green you can. The canvas is set to screen space camera, and I assigned main camera as a render camera and set plane distance to 1. So you should see it in most cases. It's not a perfect setup, but it's good enough for our demo. And let's see. Anubis is set up with rigid body. I freeze the rotations on X, Y, and Z. Mass doesn't really matter. And I use gravity. It also has box collider, but you can use capsule collider, whatever collider. It doesn't matter for now. And we have animator, which is pretty important. So I have here a blend tree. So you do create state from new blend tree and you will get empty blend tree. So what I did here, I created two parameters, X and Y. When you click on blend tree, you have to select blend type 2D freedom directional and press this plus and add motion field. Drag your animations here. I have idle, run, run back, strafe left, and strafe right. I set the position for these points. So for example, for run, we have point 2, which is by Y, which is up. And for run back, minus 0.2 by Y, which is back. So if we play this preview, I can show you how it works. So right now, everything is at 0, 0. But once we start moving, so we move the thing towards strafe right, and you can see he starts strafing right. If we move it to the left, he starts strafing left. And if we move it to the front, he starts his Naruto run, and back is backwards Naruto run. Also, if you move it somewhere in between, it tries its best to mix the animations, so it's kind of looks organic. And at 0, 0, 0, we have idle. This will be controlled from the script. This is our blending machine. That's all we need for animation. Okay, so let's check our script. So it is called Anubis Tracer controller because it's Anubis, but it's Tracer at the same time. Let's see. I had commented out, I had a lot of comments for you, so you can just read if you don't want to listen. This is about 200 strings, not very big, not very small. So let's see what we actually need here. I defined some things like rigid body and animator from the same object that the script is on. All it does is just returns get component, which is lazy, non-efficient way, but that's not that important for this thing because we're learning how to do logic, not how to get a component. So I set up the speed and rotation speed for the character. That's how fast it goes back, forth, left, right, and how fast we rotate the camera when we rotate the mouse. Then I set a couple flags. So first is recalling and second is blinking. Basically, if the recalling or blinking is in effect, recalling is when we go back in time for 3 seconds and move the character to the exact position and exact rotation where he was 3 seconds ago. And blink is like a charge. You blink to the front, 3 meters to the front or 3 meters into the direction of the movement. Then I have flags if it can recall now or can blink now. We will need it to check when the player presses the button if he can actually execute the action. Then we have blink charges. The mechanics of the blink that we accumulate charges and then we can blink with short cooldowns when we have charges. Once we don't have them, we can't blink. We have to wait until the longer cooldown passes. Then active path tracking. We will have a coroutine that we want to save. This coroutine will save the data about visited positions and visited rotations for last 30 of them, which is approximately 3 seconds because I do the step of 0.1 second for each when I write them, but you will see it later. So when I run a coroutine, I save it into this active path tracking. I save it so I can stop it once I start recalling, so it doesn't write new positions while I'm recalling, because it just might mess up everything. And we have a reference to our blink charge text. So the ones that you saw is right. It's this one. Okay. So awake. That's basically a place where we set up. Awake is executed first once the script runs. And here we set lock state for our cursor. What it does, it fixes your cursor in the center of your screen. And also, I think it hides it also. So when you move your mouse to the right, it will be like in shooter. So you move your whole screen later to the right once you read the data, and not like moving your cursor, because it would be really annoying if your aim in Counter-Strike, for example, will move with your cursor on the screen. So for example, your aim would move to the top left. That would be pretty stupid, right? So we start a coroutine to keep our track, to keep our path, to track our path. So here's this coroutine. We will talk about this one later. But the main part here is that we are actually saving it so we can stop it later. And we start a coroutine to add charges. This will be the coroutine that will constantly add charges once it can add it. So basically, if we have less than 3, then it will wait for 3 seconds and add 1. And we set the initial values for recalling and blinking thingies. So active state is false for both and can do it true for both. So we don't have to wait for the cooldown. It's already active for use. So let's look at add charges coroutine. It does it infinitely or until we exit the game, more or less. We check if we have exactly 3 charges. If we do, then we just continue. So what it does, it waits for 1 frame. You'll return null, means wait for 1 frame. And then it continues. Continue will just skip this whole thing and start the new cycle of the loop. So loops are just going like this. So execute it once, execute it second time, execute it third time. What continue does is, like, if we're on the second time, it doesn't execute whatever is here. It will just go to the next third cycle. That's it. Technically, we don't really need it, but it's a nice thing to know how it works. Because here, anyway, if we are here, it won't go here. All right. And if we have technically less than 3 charges, but if we have more also, but since it's not possible in our game, it doesn't matter. Because here we check only for 3 and we don't check for more or less. So everything that is more or less than 3, we'll wait for 3 seconds and add another charge. So blink charges plus plus will add 1 charge to our blink charges. And it will do it only if we don't have 3 charges exactly. Okay. Adding charges is pretty basic. I think you can figure it out, especially if you try it. Keeping track of the path. So we start another coroutine that we have infinite loop in. So while true is an infinite loop, which is usually a bad thing, but sometimes you just need it because update technically is also an infinite loop. We're just waiting for the frame at the end. So we're just kind of running a separate update in this function, in this class, sorry. So there's 2 ways that we can actually exit this loop. One is exiting the game, and another one is when we stop the coroutine because we saved this coroutine. This is this keep track of path. And we started in the beginning and we saved it. Later I will show you where we actually stop it. So 0.1 second, wait, then add the position and add the rotation to appropriate list. And if we have more than 30 positions, then we remove first the oldest, more or less, first in the list, which will be the oldest, position and rotation. That way we always have like 30 values here. And that's exactly how much we need for 3 seconds. Then let's go to update. First, we deal with text, the one that we saw already, this one. So we deal with indicators more or less. We set the text to amount of blink charges. Then we check if we can blink and we have enough charges to blink. Then we set the text color to green. If not, then we set it to red. That means that we can't blink right now. Then we initialize 2 vectors. First is move vector and second is mouse rotation. We initialize it both with 0 vectors. One is vector 3, another one is vector 2. But it's not that important. I think we can make both vector 2, but it doesn't matter right now. So mouse rotation. We take the data from our mouse input. This is how you get the left and right movement of the mouse. This is how you get up and down movement of the mouse. And we save it in the mouse rotation vector. It's called mouse rotation because we'll use it later for rotation. So X into X, Y into Y. Then we get the input for WASD buttons. So that's our movement front, back, left, right. And we save the vector that it should move into direction to into move vector. So for example, we press W, we save the forward of our character into move vector. If we press W and A, let's say, we we would save here forward and left, so right minus. Here is minus. So this will be vector 45 degrees to forward and left direction, more or less, in the middle. Yeah, I think with directions it will be pretty clear once you try it. Then we check if we're right now recalling or blinking. If we do, we set on our animator. Here we get our animator. We set X and Y, which we had to set, let's see, as parameters here. So here's animator. When you select your character, if you edit animator component and edit animator controller, I called mine animator Anubis, and here's mine. So here's layers, here's parameters, and you can press this plus and add a float and name it whatever you want, but I named my X and Y. Also, in your blend tree, you have to select parameters for X and Y, so I just selected X and Y, which is pretty logical, I think. So I set it to 0, which in my case will mean that it plays idle animation, because when I'm recalling or blinking, I don't want it to like run or something. I just keep it idle. And we stop the execution of update because we return. We do that because we don't want to execute any further movement, because the movement will be done in either recalling or blinking. And we will continue with update only once either recalling or blinking is finished. But in case we're not recalling and not blinking, we check for the player to use recall or the blink. So first we check for the blink. If the player pressed left shift and he has any charges, so it's if charges are higher than 0, or and he can blink, so basically if it's not on the cooldown, then what we do, we start the coroutine of blinking and we pass a vector there, which is our direction. Remember this vector, move vector, that we got by accumulating our input and transferring it into the direction? So we just created vector 2 based on X and Z of this vector, because we don't care about Y for the direction, since the movement is technically 2D for our game. We don't go up or down. That you can figure out on your own if you want, but most likely you won't need it. So once we start blinking, we just return. And that means that we do not continue the update. Only on the next frame it will be called again. If we are not going to blink, then we are checking for recall. So key Q, same as Overwatch, I believe. And if it can recall, then we stop the path tracking. Remember, we saved this coroutine of keep track of paths into active path tracking. And here's the place when we stop it. So we don't mess up the positioning when we're recalling back. We just stop it and we keep the data that was saved once we started recalling. And we start the recall coroutine itself. And we return again, so not continuing this. But if nothing was actually called, like from our skills, and we're just moving, then we call rigid body move position, which will move our character using physics to specific position in the world. So our position is the one that we want to move it to, is our current position plus movement vector. So movement vector is the vector that we calculated here, multiplied by speed. The speed is 5, and multiplied by time delta time. We multiply by time delta time to compensate for different time when the frame is called. So for example, one frame can be called in 100 milliseconds, second one after 200, third one after 300 milliseconds. Because frame rate, it jumps. And that is how we compensate it, because we multiply by the part, by the second, by the time which passed since last frame. And yeah, basically it's only part of the second. And if we calculate our speed based on seconds, that's how we get the time for this frame from the distance that it should go in 1 second. I hope that's clear. But yeah, if you remove time delta time and you just set speed to something lower, it will also work, but it might be jumpy when your frame rate jumps. So it might move at different distances every frame. And then we basically set our new rotation. So this is the shift that we calculate based on mouse rotation X. So if we move the mouse to the left or right, it will change the mouse rotation X, because we got it here. And we create a basically new quaternion with earlier angle Y set to mouse rotation multiplied by rotation speed. This is just for our shift. And then we do rigid body move rotation, which will rotate our rigid body using physics. So it's not the same as transform.rotation. This is actually the method to move stuff, not to set the exact rotation like for transform. Because if you do this for rigid body, then it actually calculates physics with this rotation. Same reason why we do it for rigid body move position, because this way it can figure out that it actually hits something, for example. So we calculate the next rotation by multiplying our current rotation by the shift. With quaternions, if you want to more or less mentally in your head add them, you actually have to multiply them. So if this was at angle 10 and this was at angle 20 by Y, if you want to have 30, you have to multiply it. That's how it works, more or less. Okay, and now the difficult part. So our problem is that when we use our blend tree, we have to set the positions to, for example, if we look forward and we move forward, then we can just pass our direction, and it will be something like 0 and 1 by Y, which we pass Z into Y, but that's okay. So if we look forward and we move forward, then the position that we will pass will be this one. So our character will move forward. But if we look right, for example, and we move forward, if we just set our current movement direction, it will be like this. We will still move forward, but animation will be to move right. So to fix that, we need to do some calculations. We need to calculate the angle between forward. I want to show it to in code. So we calculate the angle, signed angle, so it will be from 0 to minus 180 or to 180. we calculate the angle between our move vector and the world forward. So if we look here, here is the world's forward, and our move vector is, for example, if we press forward and we will rotate it to the right, it will be this. So the vector will be 90 degrees, let's say. Even though we pressed forward, the world forward is here. Our forward is here. We need this angle so we can rotate our forward 90 degrees here. So what we do, we calculate this angle, which will be 90 degrees, and then we multiply our forward, but only x and z from it, by these degrees. We basically rotate it. So after we rotated our forward vector, we calculated animation vector. In this case, the world forward is here, our forward is here, animation vector will be here, even though our forward is here, because we are moving forward. So on the animation part, we should also move forward. That's why we calculate. That's complicated, but you can figure it out, I believe. Yeah, that's just some pure math. You can actually try to copy that and play with it. Then if our move vector is 0, then what we do, we set animation vector to 0. So we ignore this calculation and we just going to be idle. So if we're not moving, we're idle. And then we set animator to our animation vector. Normalized, which means if we had values higher, yeah, it tries to fit everything into 1 by 1 square. Well, from -1 to 1. So if you had, for example, vector of 20 and 30, it will shrink it down and you will have something like 0.2, 0.3. So when we actually look at our thingy here, it will be, oops, 0.2 and 0.3. Yeah, something like this. Yeah, our maximum value is 0.2, that's why it's not allowing more. But you can technically have maximum value set to 1, and then you can have more variability. I just wanted it to be really close, so the difference here is not that big. Okay, so let's see. Yeah, that's all that happens in update. Now let's look at the actual skills. So when we start our blink coroutine here, that's what it does. First of all, it sets the availability for the blink to false, so we can't blink, and sets the active state for it to true. That means that we're blinking right now. It decreases the charges by 1, so we have 1 less charge after we blinked. We initialize the target with 0, and target is our final destination where we want to blink. We try to raycast to the front to see if we have any obstacles. So we raycast from our position to basically the direction of our movement, also normalized, and distance of 3, and we save it into hit. Hit is raycast hit type, which will have a point that we're gonna get. So we set, if we hit something, then we set our target to a new vector of this hit point, so exactly the point where we hit, we take x and z from it, but the y coordinate we set to the coordinate of our character. So he doesn't jump up or down, no matter where it hits him, he just stays. And if it didn't hit anything, we just move forward. Oh, sorry, we just move into the direction of our movement and also multiply it by 3. In case we don't move at all, so if move vector is 0, we just teleport forward. So default direction is forward. Forward of our character, normalized and then multiplied by 3. Okay, that will basically make the length of our forward vector 3. So it will be the distance of 3. Then we have to save our start position, basically where we start blinking, and we do the lerp. Lerp allows you to pick the value between 2 different values at some specific percentages. So from 0 to 1, if you look at this, it will interpolate between 2 points from A to B. Basically, point A is starting position, point B is our target, and the place in between this, percentage-wise, will be T. So it will be from 0 to 1. In our case, it will be our LRP, so values that we use to lerp. We start at 0.1, and we add 0.1 in our loop every frame because we wait for yield return null until it reaches 1. I think it's 9 or 8 steps, whatever. And we set our position to the result of this lerp. So for example, if we are moving from 0 to 1, so on first step it will be 0.1, on second step it will be 0.2, etc. If move from 0 to 2, on first step it will be 0.2, then 0.4, etc. Lerping allows you to smoothly move from one value to another. And you can lerp vector 3, vector 2, you can lerp floats, you can lerp whatever you want. Yeah, and once we've finished moving, then blinking set to false, and we start the blink cooldown. Blink cooldown is another coroutine which basically waits for half a second and then says, okay, we can blink again. Recall, that's our second skill that's coming from Overwatch Tracer. It's pretty simple also, because everything is simple here, you know, comrades. So recalling, true. Can recall, false, because we can't start another recall, but we recalled right now. So we go from the last position to the oldest positions that we saved. So from the count of this list to 0, from count -1, and we decrement instead of incrementing our iterator. We do the same thing with lerping, and we lerp from our current index to our next index, which will be one less than the current. Basically, we're going back in time. That's what we need. And we set the position and rotation to this specific index, but somewhere in between lerping values. So again, we get last, and we're going from tail more or less. So last, one before last, etc. Then we try to move from our current index to the one that we were even before. So let's say we moved from 0 to 3, and our position right now that we're checking is 3. The next one will be 2.9, and we're moving from 3 to 2.9 using lerp, which will just move like 3, 2.99, 2.98, etc. So it will slowly move between these 2 points. And then once we move between these 2 points, it will just switch the index, and we will move now from 2.9 to 2.8 until we just finish our list of positions that we saved. It will approximately take 3 seconds to move through the whole thing. After we are done, we set is recalling to false. We clear our rotations and positions, and we start a new coroutine that keeps track of them. So we save them again, and then we set the recall onto cooldown for 6 seconds, and we can recall after that again. So here is our script. I know that's overwhelming, especially compared to previous tutorials, but that's really cool stuff, and it's used in real game. A little bit more complicated version of it, of course, but still. So let's just try our game one more time. And before we go, I want to ask you to subscribe to my channel, because most of you who watch these tutorials are not subscribed. So you can see I'm walking and animation is playing based on where I'm moving. I turn my mouse and you can see that the character rotates. Okay, you see the mouse, but now I click and you don't see it because the window wasn't in focus. You can see that the value that I have is 3, which means I have 3 jumps available, 3 blinks. Now I press shift and it blinks forward. Now I move to the left and I press blink and I blink to the left. Then again, I move closer to the box and I blink into the box and it gets stuck in it, so it doesn't blink through. And what I can do, I can blink out of the map, press Q, and I returned. So I hope you enjoyed the video, and please subscribe and put a like to my video. Comment if you haven't understood anything or you want some specific tutorial next, and see you in the next video.